Alrighty, good morning class. So this is kind of a part 2 of our 4.6 notes, and we were on the extra practice. What we did is we took our pre-image points and we translated x minus 5, y minus 3, and we gave a vector form -5, -3. That's the vector form of this. And then we took these points, plugged them in to where 3 minus 5, we got -2. Then we had 6 minus 3, and we got 3. And so now we have our first image, or image 1, down here. And so we're going to move on to our next transformations, where we're dilating the figure by 3. But you want to do the shortcut version. If you haven't noticed, you'll take your scale factor and you'll multiply it by your new point. And so you'll have 3 times your -2, and you'll get -6. And then you'll get 3 times 3, which is 9. This is your pre-image that you're starting off with. And so I got this, again, by doing -2 times 3 and 3 times 3. So I took my scale factor and multiplied it by its coordinate points. And so when we do the rest for all of them, I have B double prime is -9, 6. C double prime is -3, 0. And D double prime is 0, 6. And so I'm going to graph this one as well. I'm going to use a pencil because it does overlap over our first image. And so please don't be alarmed when I do use this pencil. Okay. -6, 9 is A double prime, and B is -9, 6. Okay, and so there is our dilated image from our first image. So make sure that second part, you're taking your new points and you're manipulating the new points that you get, not the original, because then it'll be over here, and that is not our second step. So now we're going to do example 2. So I have R, S, and T. R is 12, 8. S is 8, 0, and T is 0, 4. So here's R, S, and T. So I have this nice, lovely triangle as my original image. Now it's asking me to dilate the figure by 1/4. And so here's the key trick when talking about dilation. If my K, or my scale factor, is smaller than 1, so pretty much a fraction, make sure it's a small fraction, then it's going to get smaller, or it's going to be a reduction. Okay, that's reduction. Now when K is bigger than 1, okay, and that can also be an improper fraction if you turn it into a mixed fraction, that becomes bigger, or an enlargement. Okay, so those are some key notes to add about dilations. So I'm going to dilate this figure by 1/4, a scale factor of 1/4, and so I'm going to multiply 12 times 1/4. And when I do that, I have 12 times 1 is 12, and divided by 4 is 3. And I will do the same with 8, and I get 2. Alrighty. And I'll do the same thing with S prime. So I take my 8 times my 1/4, and so that's my X value, and take 0 times 1/4, and I get 2, 0. And then for T prime, I end up with 0, 1. Okay? So now I'll do reflection is my next step. So let's graph our first image. So there is our dilated figure pretty much 1/4 of the size of the original, okay? So now it's asking us to reflect it over the y-axis. And when we reflect it across that y-axis, the x changes. It's written really small, this is x changes. So when that happens, I'm changing the sign. Okay, so now I'm going to reflect it over the y-axis, and so my x value changes, and it changes the sign. So if it's a positive 3, it now becomes negative 3, 2. So the x value changes its sign. And so that means s prime, double prime, turns into negative 2, 0, and t double prime, I can't really have a negative 0, so it stays just 0, 1. Okay? And so remember, our x value of the sign changes from our new value, not from the original. Okay, so we're reflecting it over. So I still have negative 2, 0 now. And then I have negative 3, 2. Okay, and so that is our reflection over the y-axis. Down to our third example, I have x, y, and z. I have 10, 5, 4, 2, and negative 2, 5. And we are actually not going to do the dilation because our center is different. We're focusing mainly on practicing rotation. And so let's graph our original points. Okay, and so here is our original figure. And so when I do that, and now I'm going to rotate it. And so our rule for rotation is that we switch them, switch our coordinate points, and then our negative b or our positive b actually changes its sign. So if we switch them, and if b is positive, it becomes negative, or if it's negative, it becomes positive. So we end up changing those signs. So x prime now becomes, when I switch it, 5, 10. But 5 is positive, so now it becomes negative. So y prime is now negative 2, 4. And z prime is negative 5, negative 2. Okay? And so when I graph that, it does go off the grid a little bit, and that's perfectly okay. I have x prime up here. And down here I have 5, negative 2. And negative 5, negative 2 for z prime. And then y prime is negative 2, 4. So it did rotate 90 degrees, and make sure that was counterclockwise. Okay? Alright, so on to our next example. Next 3 examples, we are actually describing what is happening to our similar transformations. So for this one, I noticed it got smaller, so I know I have a dilation. And I know that it slid over some, so I also have a translation. So if we're talking about the dilation, always think of how many counts you have of your pre-image, or your image, I'm sorry. So your image over your pre-image. So think about those counts. So from our image, we have a count from n prime to n prime is 1. And then from n to n, I have 2. Now note, if we do the image over the pre-image, I now have 1 over 2. And I know that this works because I know that my image is smaller than my pre-image. So we had a dilation scale factor of 1/2. Now translation, I moved over. If I go from n to n prime, 1, 2, 3, 4. 4 to the right. And then I actually went down 4. Okay? Alrighty. Let's see if you can try number 5 upon your own. You notice the obvious that I did a dilation. But think this is our pre-image, this is our new image based on the primes, and there is a reflection that happened. Maybe you can tell me the details what happened here. And number 6, I obviously had a dilation. And you might think I had a reflection, but I did not. Think about where S and R are located. So I actually had a rotation. And I had a rotation over to the left, 90 degrees, counterclockwise. But say I went the other direction, it's 270 clockwise. Okay, and you can always find that by, I know I went 90 degrees one way, and I subtract it from the rest of my circle, and I know I would get 270 degrees going the other direction. And this way I have a dilation from our image over our pre-image. This is 1 and 3, and I definitely had a dilation scale factor of 1/3. Okay? That concludes our notes. I kept them short today, and on the back page for 4.6, just cross off numbers 6 and 9. Thank you.